Okay, ladies and gentlemen, let's move on. We've already done the 3.4 part 1 video. Now I'm ready to move on to the kind of compound inequalities that I teach students to do by using what I call helper graphs. So, we're asked to solve the compound inequality. It's a compound inequality because it's two inequalities joined with the word and. Now, this is basically a three-step process. Step number one is to not even pay attention to the word and or to begin with. Step one is to look at the first inequality and solve for x. And this one's fairly easy. We simply divide by 2 to get x is greater than or equal to -5. We look at the second inequality. We get x alone. We do that by subtracting 1 from both sides, and we have x is less than 8. Now, that's step one. When you're solving a compound inequality, joined by the word and or joined by the word or, solve for the variable, whether it be x, y, z, it doesn't matter. Solve for the variable. Okay, now here's what you're going to do next to help you get the answer. You're going to draw what I call helper graph 1. And you're drawing all numbers that satisfy the first inequality. So x is greater than or equal to -5 would look like this on a number line. Bracket on the -5 going to the right. X is less than 8 is going to go on what I call helper graph 2. Paren on the 8, since there's no equals, all the way to the left. Now, the word and means intersection. What you're looking for now is you're looking at helper graph 1 and helper graph 2, and you're trying to see what numbers they have in common. In other words, it has to be on helper graph 1. It also has to be in helper graph 2. And you put that on what I call the answer graph. That's our solution set. Well, what numbers? Where do these two sets meet? Well, hopefully you can see the only numbers that are in both sets are the numbers between -5 and 8. So, I put a bracket on the -5. I put a paren on the 8 because 8 is not included in our answer, and I shade in everything in between. That is my answer done as a graph. Now I turn the graph into interval notation by writing bracket -5, comma 8. Always read from left to right. And the final notation we were asked to use was set builder notation. And of course you always start off by writing the set, those little squiggly things, the set of all x's. The line is called such that. Now, the way you write this answer, this is a sandwich. I put the -5 on the left, I put the 8 on the right, and I put the x in the middle. Whenever you're writing a sandwich, excuse me, I need to stop my doggies. Doggies, hush, Daddy's making a video. Shush, get up here, Zeus. Sorry about that. Come up here by Daddy. You calm down now. I'm doing a video. Okay. Notice, whenever you're writing a sandwich, the inequality signs always point to the left. And I put an equals under the -5 since it includes it, and I don't put an equals under the 8. This really says x is greater than or equal to -5 and x is less than 8. All right, let's try another one. Okay, here is another example. This is also a compound inequality. This one's joined with the word and. Remember what I taught you step 1 is. Solve for x. So we distribute the 3, we subtract 3 from both sides, and we divide by 3, thus giving me the answer x is less than 3. On this one, we distribute the -2, so we get -2x minus 2 is greater than or equal to -12. I add 2 to both sides of the inequality, giving me -2x is greater than -10. And I divide by -2, which causes a sign reversal. X is less than 5, right? -10 divided by -2 is 5. Isn't it, Zeus? Yes, it is. Okay. Now, we come over and draw our helper graphs. Helper graph number 1. X is less than 3, so this is what I draw on helper graph number 1. A paren, not a bracket. X is less than 5, I draw that on helper graph number 2. Now, when I use the word and, which means intersection, what numbers do you see in helper graph 1 and helper graph 2? Now, sometimes when I'm teaching, students will make a mistake and they'll say, oh, we see everything in between 3 and 5. No, you don't. There's nothing on helper graph 1 that goes past 3. It's all to the left of 3. So if you're really paying attention, if I said to you, highlight what these two have in common, I'm highlighting it for you right now. It's the area below 3. That's my answer. Everything everything to the left of 3. Remember, this direction that I'm pointing at is negative infinity, so our interval notation would be negative infinity, comma 3, both with parens. And if I write this in interval notation, in set builder notation, it's the set of all x's such that x is to the left, i.e. x is less than 3. Whenever you're using set builder notation, letters are required. When you're using interval notation, I don't want to see a letter. When you're using a graph, I don't want to see a letter. So the only time letters appear is if your instructor has asked you to write the answer in set builder notation. Otherwise, there should be no letters. Okay? All right. Okay. That's enough for this video. We're going to call this 3.4 Part 2.